In this video, we'll use factorial, double factorial, and gamma to generate the Taylor-Maclaurin series sum of this function x times e to the minus x. We begin with the function itself. So array formula x1 times or x values times exponent of minus x. And we'll chart this. We insert chart and we'll use scatter chart. And show the trend line. Polynomial to the 8th degree. And use the equation as header. And the legend position at the bottom. So here's our trend line and the polynomial of the trend line to the 8th degree. And we generate the Taylor-Maclaurin series sum, which is the summation of a times x to the power n. A can be a1 or a2 or a3. And the value of n is from 0 to infinity. So we start from 0 to infinity. 16 is good enough. We continue with the coefficient using the gamma, which is array formula. Minus 1 raised to the power the quantity n minus 1 divided by gamma of n. And enter. So if n equals 0, it should be 0. Because at n equals 0, it should be 0. So we copy this. So use the if statement. N equals 0. And it's 0. Otherwise, calculate. We continue with the double factorial, which is equal to array formula. Minus 1 raised to the power the quantity n minus 1 times, that's the first part, the second part, times n divided by, now there are two parts, double factorial. So factorial double factorial of n. That's the first part, times the second part. Again, factorial double n minus 1. So n minus 1. And enter. They're exactly the same, except the first item, it should be 0. So we'll correct that. We'll use this condition, the first portion of the formula, and replace this one, this portion of the formula, and paste. Now they're all the same part. They're exactly the same. We continue with the factorial, which is array formula. Minus 1 raised to the power the quantity n minus 1. And minus 1 divided by factorial, again the quantity n minus 1. That's the factorial. The denominator, again we have the same problem, although the other parts are the same. We'll correct that using the same formula we have copied earlier, paste. So if n equals 0, 0, otherwise calculate. Now it's corrected. Now we can calculate the expansion. So array formula, series sum of the x values raised to the power n. So where n starts from 0. So n starts from 0, incremented by 1. And the coefficient, there are 3 to choose from. We'll choose the factorial. Then enter. We'll change the chart. We'll edit this. We'll show the trend line. Edit chart. Series. Trend line. Polynomial to the 8th degree. The label, use the equation. The legend's already at the bottom. So you get the trend line and the trend polynomials. We'll calculate these regression coefficients using Linest. To do that, we complete the Linest matrix, starting with the power, which is equal to transpose 0 to 8, because it's the 8th degree. And the elements of the matrix are a formula of the x values raised to the power 0 to 8. And now we can calculate the polynomial regression coefficient using Linest. Data y and data x. Enter. Likewise, the expansion Linest, data y, and data x. And so let's compare the coefficient of x to 0, 0. This is already 0 times 10 to the minus 31. So 3.49, 3.54, that's already 0. Coefficient of x, 0.999. Coefficient of x squared, negative 0.997. Coefficient of x cubed, 0.493. Coefficient of x to the fourth, negative 0.159. Coefficient of x to the fifth, 0.0354357. Just a slight error. Coefficient of 8x to the 6, x to the 6, 5.44 times 10 to the minus 3, 5.55 times 10 to the minus 3. There's a slight error because this expansion is only an approximation. So this is the exact value, but this is the approximation. And x to the 7, so 5.15 times 10 to the minus 4, 5.35 times 10 to the minus 4. And x to the 8, 2.25 times 10 to the minus 5, 2.4 times 10 to the minus 5. That's because I'm using the factorial. Suppose I replace this, I will use the double factorial coefficients. Let's see. The polynomial regression coefficients are the same. There's just a slight error here, but they're still the same. The polynomials are the same, and the trend lines are still collinear, and the datasets are also the same. So let's use the gamma function. Let's use the gamma function. And enter. Here we have the datasets still the same. The trend lines are still the same. The polynomials are still the same, just approximately up to this portion. And the polynomial regression coefficients are still the same. So there's just a slight error here. This completes the use of factorial, double factorial, and gamma in the Taylor-Maclaurin series sum expansion of this function x times e to the minus x.